So this assignment related to alkanes and alkenes. We did first 8 questions, the first previous session. Today we'll do 9 onwards. A compound butane has. So which statement is correct about a compound butane? Butane is but means 4 carbon and it's alkane through the general formula CN H2N plus 2. So C4 and H4 multiplied by 2 makes it 8 plus 2 10. So C4H10. And what about the empirical formula? This is a molecular formula. Empirical, the simplest ratio, that will be 2:5. So empirical formula 2:5, and the molecular formula, which represents the actual number of atoms, that is why B is the right answer. The next question, ethane is exposed to ultraviolet radiation, UV radiation. Ethane react with chlorine when substances are exposed to UV radiation. This equation for the equation for this reaction is the overall equation we need. That is a substitution reaction which occur. So in a substitution reaction, what happened, like ethane is C2H6 and reacted with chlorine Cl2. One chlorine will take position of hydrogen at the same time. Hydrogen will take the position of chlorine, so it will form C2H5 Cl plus Hc, and that's why option A is the right one. The role of ultraviolet radiation in the reaction is to, so what is the purpose of UV rays or ultraviolet radiation? So it will produce chlorine free radical. So due to the ultraviolet radiation, homolytic bond breaking will occur and it will produce a chlorine free radical. So it breaks the chlorine bond and forming a chlorine free radical. That's why A is the right answer for this. The overall reaction between ethane and chlorine is best described as, so what we call this overall reaction, this is a substitution reaction or free radical substitution reaction. So D is the right answer. Which of these compounds shows the geometrical isomer Z or cis class? So how to identify if identical groups are attached between the carbon-carbon double bond, it cannot show a geometrical isomer because we cannot compare. So if we see this carbon, this is having 2 hydrogen, one hydrogen here, one hydrogen here. So we cannot compare which one is a heavy group as identical groups are attached. So this cannot exhibit a geometrical line. Here, this will have hydrogen and hydrogen. So, and one side carbon chain is there. So we can compare, it can show a cis and cross. When we check for this one, because we check the 2 carbon which are having a double bond. So this carbon will have hydrogens. So 2 identical groups are attached with the same mass. Same thing, these 2 carbon, but this is CH3, this is also CH3. So we cannot compare which one is heavy. That's why they cannot exhibit geometrical isomerism. So B is the right answer. The correct name for a compound shown below is, so the structure for this one, I will add a structure for this one. Moving on to question 15, alkenes are unsaturated hydrocarbon because of their relative reactivity. Industrial starting materials, alkene for industry uses are obtained by cracking of alkanes. Write an equation for cracking of decane to form one molecule of propene and as a only alkene. So we want a propene as a only alkene. So C10 H22 crack to give propene. Prop means C3 H6 plus. Remaining out of 10, 3 are there, so C7 will be there. And out of 22, 6 are there, so we'll have, because one is alkane, the other one should be alkene, or one is alkene, the other one will be alkene. So this is a cracking equation for decane. Carbon-carbon double bond in alkenes consists of a sigma and a pi bond. Use a diagram. The difference between sigma and the pi bond. So sigma bonds, what are sigma bonds? Which are formed by complete overlapping of the orbital. And what are the pi bonds? Which are formed by partial overlapping. If you want to represent a sigma bond, like this is one carbon, there's another carbon, so the orbital will overlap with sigma. But what about pi bonds? When the axes are parallel, but the orbital cannot overlap, so they will have an attraction. This will result in a formation of pi bond. So sigma bond, when we mention that due to complete overlapping, and the pi due to partial overlapping. State the type of mechanism involved in state the type and the mechanism involved in typical reaction of alkene. So alkene, what kind of reaction alkene will undergo? So it is electrophilic addition reaction. So type is electrophilic and mechanism is addition. And if the same question was there, type and mechanism involved in alkanes, then we will mention it is free radical and mechanism is substitution. By considering the strength and the structure of double bond, why alkenes are more reactive than alkane. So what is the reason why alkenes, the reactions of alkene are much stronger than alkane or much faster than alkane? Because pi bonds are weaker bonds, so it can break easily, or pi bonds have a high, because double carbon-carbon double bond is there, so it will have a high electron density, so it can easily attract the electrophile, or electrophile can easily attack on them. So by considering the strength of a carbon double bond, why alkenes are more reactive? So alkene contain carbon-carbon double bond, which is having a weak pi bond and high electron density. So electrophiles can be attracted. So when propene react with hydrogen bromide, there are two possible products. Draw a discrete formula of each of these products and label the major product. So we just have to draw the final product when propene react with hydrogen bromide. So what are the possibility? If I draw the structure of a propene, this is propene. So if it is reacting with hydrogen bromide or HBr, hydrogen might attach to first carbon and bromine second, or it can be hydrogen might attach to second carbon and bromine with the first. So if hydrogen attached to the first carbon, the double bond will break, and bromine with the second. So it will be 2 bromo propane. And if hydrogen attached to second and bromine with the first, then it will be 1 bromo propane. Now, which one will be the major product? How to identify which is a major product? Because if first hydrogen will be attached to, if a carbon cation is formed, so this will be the carbon cation. And if hydrogen form a bond with the second carbon, so this will be the carbon cation. So which carbon cation is more stable? The first left hand side or the right? Which carbon cation is more stable? So on the left hand side, because it is having more alkyl groups surrounding, so that's why, which will be the major product. The major product will be 2 bromo. So 2 bromo propane will be the major product and 1 bromopropane will be the minor product. Give the mechanism for reaction of propene with hydrogen which form a major product. So we have to show a mechanism like how this reaction proceed or how this reaction occur. So first and drawing the direction of the arrow is very important. So first we'll draw propene. This is propene. Then what happened? It is reacting with hydrogen bromide, so HBr, so there will be partial positive on hydrogen, which is less electronegative, and bromine partial negative. Now, bromine, the more electron shifted, both electrons shifted toward bromine, electrolytic bond breaking, and this carbon-carbon double bond, one of the bond will form with hydrogen. As a result, what will happen? You have to show the major one. So hydrogen will be attached here. And this will be the carbon cation. And the bromide ion that is attracted, which have a pair of electrons to form a bond at the last. So this will form 2 bromopropane. Is it clear? The mechanism. So direction of the arrows is very important. When you draw, direction of the arrow is the most important. Any doubt in this? Okay. Next is explained by referring to mechanism why a major product is formed. Like, what is the reason why we have this 2-bromopropane as a major product? Because the carbon cation, which is surrounded by, or this is also called a secondary carbon cation. So carbon cation, which is surrounded by more alkyl groups, having a greater stability than a carbon cation surrounded by few alkyl groups. So the carbon cation surrounded by more alkyl groups is more stable. So in this case, it can be a secondary carbon cation. Why secondary? Because when carbon cation surrounded by, if in a major product, the carbon cation is surrounded by 2 carbon atoms. In a minor product, the carbon cation is surrounded by 1 carbon chain. So that is called a secondary, and this one is the primary carbon cation. So secondary, the second mark, you will mention that the secondary carbon cation, secondary means like if 2 carbon chains are attached, we call it secondary. If 1 carbon chain is attached to a carbon positive ion, we call it primary. If 3 are attached, we call it tertiary. So carbon cation, secondary carbon cation is more stable than primary cation, carbon cation. The polymer polypropene is manufactured from propene. Write equation for the polymerization. Draw the displayed formula. So there's a small space available here. You have to draw the structure for polypropene. But first thing, your monomer should appear like letter H. So you will always rearrange it. And as I mentioned, a displayed formula. Displayed formula means the formula which represent all the bonds. That's called a displayed formula. So even like if this is propene, which is CH2 double bond CH, then CH3. This is not a displayed formula. This is a structural. So we have to draw first, rearrange the monomer as letter H. So when we rearrange the monomer as letter H, so we will have two carbon atoms, one hydrogen up, one hydrogen down, and this, even I cannot write CH3 because I have to keep in mind it is a displayed formula. So I have to show all the bonds. This I cannot write CH3, I have to show all the bonds here as well. Now to draw a polymer, because we have to write equation. So if we have n molecules of propene, as a result, the double bond will break, turn into a single bond, and there will be repeat units, and we'll put a bracket and then n. So this is the equation that if we have n molecules of propene, that will result in a formation of polypropene, a long chain polymer. The ultraviolet radiation, UV radiation, cause a polypropene to degrade. So just one advantage and one disadvantage. So what is the advantage? Advantage, the polypropene will decompose naturally. But what is the disadvantage? So disadvantage is we cannot use it outdoor, or it cannot be recycled or cannot be reused. So advantage is that it can decompose naturally. So it does not take up the space in a landfill. But disadvantage, we cannot use it outdoor. As I mentioned, if ultraviolet it is exposed to UV radiation, it will start to degrade. So we cannot use outdoor. Or cannot be recycled or cannot be reused and start to decompose when it is exposed to bright light. Question 16. Which of the following is the correct order of processes used to obtain petrol from a crude oil or petroleum? So first what we do, we have a crude oil. First we do fractional distillation. Petrol is actually octane. And first we do fractional distillation. After doing a fractional distillation, we reform, like converting into branched, as it branch hydrocarbons can burn easily and more volatile. And then after reform, like first crude petroleum is there, then we do fraction distillation. After fraction distillation, we reform and then we obtain the petrol. So D is the right answer for this. So in this reaction, in the reaction between ethene plus bromine, it will result in a formation of a bromine molecule act as an electrophile. So ethene plus bromine will give 1,2-dibromoethane. This is for arrow. Which statement is true? In the previous, no, actually it is copied twice. So it can be A or D, it's the same thing. In question 16, the two options are copied twice. That's why, like even B and C are same. Petroleum reforming fraction distillation petrol. And A and D are also. So it can be A, it can be D. Same thing. I was reading the option D, that's why I said D. In question 17, so what is the meaning of electrophile? Electrophile refers to electron loving group. So a substance or a molecule which is attracted. So ethene act as a new, which statement is true? So ethene is C double bonded with C, H is there, H is there, H and H. Then the bromine molecule, there will be partial positive and negative. So bromine partial positive attracted towards the carbon-carbon double bond, and the other bromine will take the electron back. So bromine molecule is attracted towards the electron rich side. So this bromine molecule is refers to electrophile. And what is the meaning of a nucleophile? Nucleophile means like nucleus loving group. That's the meaning of nucleophile. And nucleus is positive. So nucleophiles, if a substance is a nucleophile, it means it is a nucleus loving or it is attracted towards the positive. And if a substance is electrophile, electrophile means electron loving group. Electron loving group means attracted towards the negative side or electron rich side. So when we check, if this was ethene reacted with bromine, which is Br2, so partial positive and negative. So bromine is attracted towards electron rich side, so bromine is electrophile. But here ethene molecule, because it gives the electron to the positive center, like it used both of these electron and form a bond with bromine. So means ethene molecule is acting like a nucleophile. Nucleophile means like the substance which is attracted towards the positive center, or it tend to donate electrons. And electrophile have the tendency to accept electron. So in terms of definition of electrophile and nucleophile, that ethene act as a nucleophile because it donate a pair of electron to bromine. That's why B is the right answer for this. Is it clear? This one? Question 17. So remember, electrophiles are attracted towards the negative part, or they tend to accept electron, and nucleophiles attracted towards the positive center, or they tend to donate electrons. Name the alkene. So first, because it is a geometrical isomer, so how to identify whether it is cis or trans or Z or E? Z means the opposite sides are there, and E is. So when we check the heavy groups, this is a heavy group in terms of mass. When we check these two, which is heavy, this is heavy. So heavy groups are on the same side, so it can be Z. But if it is on the opposite side, then it will. And now, what is the name of compound? We'll count the maximum number of the carbon atoms. So it will be 1, 2, 3, 4, 5, and 6. So 6 carbon. Otherwise, I can count 1, 2, 3, 4, 5. So this cannot be a longest chain. 6 carbon atom in a longest chain. So it is Z. So either A can be an answer or C can be an answer. Then 1 to second position, we have a double bond and 6 carbon atoms are there. And this is a branch. Third position, we have a branch, which is ethyl. So it is Z, 3 ethyl. Third position, we have a branch which contains 2 carbon atoms. And second position, we have a double bond. So it is hex. And second position, we have a double bond, so 2E. So it is 3 ethyl hex 2 E. Third position, ethyl as a branch. Second position, we have a double bond. Why I did not count from this carbon on my right hand side? Because if I count from here 1, 2, 3, 4, so fourth position I will have a double bond. But if I count from the right hand side, left hand side, I will have second position as a double bond. That's why we count from the nearest branch, nearest double bond. So a double bond is a priority. If propene react with aqueous acidified potassium manganate, so as a result, it will produce diol. Diol means the double bond will break and both groups will be attached. So if propene is there, which is CH3CH double bond CH2. So when it turn into diol, it will be CH3, CH, OH, and then CH2 and OH. So how we can represent in the structural formula? So you can see if I try to draw a structural formula, this will be CH3. Then I will have CH. Next to that CH, there is OH. And then I have CH2. And next to that is also OH. So it matches with option A. How many compounds have a formula of C5H12? Means how many isomers are there for C5H12? So possible isomers we have to draw. We may have first all the carbon in a straight chain, so one isomer. Then we have 4 in a straight chain, then branch with a second. I cannot put a branch there on my right hand side because if I put it on these two are the same structures, no difference, because this will be 2-methyl butane, this is also 2-methyl butane. So this is one, this one is two. And then what is the possibility? We may have 3 carbon and 2 branches, one up and one down. So these are the possible structure, no other possible structure for pentane. So C is the right answer, the possible isomers of pentane. An organic compound react with chlorine in the presence of UV. So in the presence of UV, which alkane undergo a substitution reaction? So what kind of substitution is there? Or reactions of alkane, it undergo free radical substitution reaction. But in the question, an organic compound react with chlorine in the presence of UV. The relative mass of a product has increased by 34.5 compared with the original. Means because why the mass increases? Like example, if I give an example, so we have methane and it reacted with chlorine. So methane carbon is 12 and 4 hydrogen, so total 60. And chlorine, so 35 point, so this is 71. When one chlorine enter, one hydrogen leave. Plus HCl. So what is the organic product, the relative molecular mass of the organic product compared with the original, it increases, but because like each chlorine is 35.5. So chlorine is 35.5 enter and one leave. So what will be the total change in the mass? The total change in the mass will be 34.5. Or you can also work out the total mass of chloromethane, which is carbon is 12 plus chlorine is 35.5 plus hydrogen 1 into 3. So this will be 50.5. So when you take a difference of 50.5 and 16, you'll find as 34.5. It is free radical substitution reaction, or A will be the right answer. Is it clear, this question 21? Next question, question 22. Chloroethane can be made by ethane and chlorine in the gas. The ultraviolet light or radiation, the equation for this reaction is shown. Complete the mechanism. For 2 of the steps have been given for you. So initiation is there, then the propagation. What happened in propagation? Like we have C2H6 plus Cl radical. As a result, it produces C2H5 radical plus HCl. And then this C2H5 radical react with another chlorine molecule. It will produce C2H5Cl plus chlorine radical. And termination, how termination happen? Like chlorine radical can join, or ethyl radical react with chlorine radical to form chloroethane or ethyl radical joined with another ethyl radical to form C4H10. So these are the steps for this reaction. By this reaction give a poor yield of chloroethane. So amount of chloroethane which is produced by this reaction is very low. Give a structured formula, name of another product not included in your mechanism which could be produced. Because it's like maybe instead of producing chloro, it might produce dichloro or it might produce trichloro. So it might produce any of the other product, like, because when this reaction occurs, it can have multiple substitution like we did for one only. But instead of producing chloroethane, it might produce dichloroethane or it might produce 1,2-dichloroethane. So we are considering only one chlorine is there, or it will be 1,1-dichloroethane. Like first position, 2 chlorine are attached and dichloro. That's why, or it might be 1,1 or trichloro will be there, or tetrachloro might be possible as well. So there are multiple possibilities. Chlorine gas is extremely toxic and is therefore significant hazard. What is the difference between hazard and a risk? So how we define the term hazard? That like hazard can like cause and harm or potential to cause and harm. Potential to do and harm or can be dangerous is called hazard. And what is the risk? How we define the term risk? So risk is basically an idea like it is a probability or chance that if we use this, the probability or chance is there if we use the substance or the procedure may cause and harm. So the chance that harm will result from use of the substance or a procedure. So definition of a hazard. Hazard is may cause harm or has the potential to do harm. Or can be dangerous. But what about risk? Risk is basically likelihood or probability or chance that harm will result from the use of substance or procedure. So these are the definitions of hazard and risk. In question 23, give the mechanism for reaction of propene with hydrogen bromide to form a major product. So major product will be 2-bromo-propane that we did in the previous one. So it's a similar thing. Next, suggest 2 reasons why cracking of a large alkane molecule is important in industry. So why cracking is an important thing or why cracking must be done? Because the main idea, the small molecules or short chain alkanes, they are having more in demand as compared to long chain compound. So the demand of the small molecule is more than the long chain. So that's why cracking is done. Shorter alkane burn more efficiently. Yeah, shorter alkanes are there. You can mention Uh, it can be recycled, waste product can be recycled, or you can mention it produce more petrol or more jet fuel. Short chain alkane or lighter fraction are more useful products or can be used as a fuel, you can mention. Or demand is greater for the short chain or lighter fraction. In question 25, how many structural isomers are there for C6H14? So means alkane, this is hexane. So for hexane, if you want to, you have to just identify by the carbon chains, like 6 carbon atoms are there. You may have 6 carbon atom in a straight chain. Or you may have 5 carbon and one branch with one. And you may have 5 carbon and one branch with the second. But if I put further right, that is also second. So it won't make difference. Then we have 4 carbon atoms. Maybe 2 branches are there attached with the same carbon, or we may have 4 carbon atoms. 2 branches are attached with the 2 different carbon atoms. Then we cannot do for 3, like 1, 2, 3, 4, 5 are there. Then if I make a 3 carbon atoms, if I try to make a 3 carbon atom and try to make a branch like this, 3 branches, actually it is not 3 branches, it is only 1 branch, because we start from here and we'll end here. So only 1 branch is there with a 1, 2, 3. So this is also 3-methyl pentane. So maximum numbers are 1, 2, 3, 4, and 5. So that's why B is the right answer. In question 26, in addition to water, which of the following could be formed by incomplete combustion? Like if it does not burn completely, what it might produce? It might produce unburned carbon, which is a black soot, and a carbon monoxide. So D will be the right answer. And polythene is a plastic material made by polymerization of ethene. Which of the following is not true? Pure polyethylene is solidified ethene. So it is not solidified ethene, it is a different thing. It composed of carbon and hydrogen, that's true. It is a long chain compound, it is non-biodegradable, that's true. But it is not solidified ethene. Polymers are not solidified compounds. It is a new substance which is formed by, it is a new substance which is formed by combination of small unsaturated hydrocarbons. So A is the right answer. Then question 28. Which of the following statement correctly describe the environmental problem caused by burning of the fuels? So when we burn the fuel, what are the environmental problems caused? Carbon dioxide produces toxic and kill plants. That is not correct. Smoke produce obscure the sunlight and leads to global warming. No, that's called global dimming, because it does not allow amount of sunlight to enter. The smoke is not responsible for carbon dioxide. Water produced result in damaging increasing in rainfall. That's not 100% correct. Carbon dioxide produced trap the heat, so that is responsible for a global warming. Then a bromine can undergo a homolytic bond breaking, and so if it's a homolytic bond breaking, how to represent a homolytic bond breaking? We represent like this is a bond, so we represent by half arrows. As a result, it will be free radical. And heterolytic means one of the bromine will take both of the electrons. As a result, it will produce bromine positive and bromine negative ion. Choose from the product in A1 and A2, write the formula for free radical. So this is a bromine free radical. And electrophiles attracted towards the electron rich side or electron loving side. So which one will be attracted towards electron? That is Br plus. So electrophiles tend to accept electron, or they are attracted towards the electron rich side. So this will be the electrophile. This is a Br minus 1 is a nucleophile. As it is having already more electrons, it will be attracted towards the positive side. Then the compound C6H14 can react. Give a displaced formula for the product that could be formed first, second, and third isomer. So we have to draw the three isomers of C6 and H13. So that you will do, like you will change the position of Br and drawing the three isomers. You can also change the structure. Then a bromoalkane and hydrogen bromide formed in this reaction are hazardous. Bromoalkane could be labeled as flammable. Suggests a suitable hazard warning for hydrogen bromide. Hydrogen bromide normally like HCl, HBr, HF, these are acidic, so acids are corrosive. So we can say they are corrosive. So we can mention it is corrosive. So these are the questions from assignment alkanes and alkenes.